Question 1. The scatter diagram shows information about 12 girls. It shows the age of each girl and the best time she takes to run 100 meters. We've got to write down the type of correlation. Well, first of all, I'm going to use this ruler to try and do a decent line of best fit. So somewhere kind of roughly in the middle. And let's see if this works. Okay, let's take the ruler away. I think that's okay. I think I could move this a little bit, so I'll just try and do it once more. Something like this. So there's my line of best fit. Now, to me, that seems to show a negative correlation. So I'm going to write that down. So for part A, we're going to write negative correlation. Now, for part B, it says Christina is 11 years old. Her best time to run 100 meters is 12 seconds. The point representing this information would be an outlier on the scatter diagram. Explain why. Well, let's put it on first. So she's 11 years old. Let's do this in blue. Take the ruler away. And she runs it in 12 seconds. So we've gone 11 and 12. So our point's going to be here. And the explanation is that this point is far away from our line of best fit. So that'll be my explanation. This point is an outlier because it is very far from the line of best fit. Now, the next part says Debbie is 15 years old. Debbie says the scatter diagram shows I should take less than 12 seconds to run 100 meters. Comment on what Debbie says. Well, let's put this to the side for a minute. Looking at the scatter diagram, the information about the ages and the times, well, the ages seem to be from around 9 3/4, starting here, up until the age of around 14. And the actual times seem to go from about 12 and a half up to 16 and a half seconds. So that's the range of the actual data supplied. Now, if you think about Debbie's age, it's 15, so it's here. So you're going to have to extrapolate or go outside of the data range. So I would say something along the lines of, let's put this around. It's quite hard to do this, by the way. It's not easy. So I'll put my explanation on and I'll say that something along the lines, it is outside the range of the supplied data, and I'm talking about the age of 15. And I would say it is therefore unreasonable to suggest that a linear trend will continue. So you don't have to write loads. You'd probably be okay just to do the first part. But what I'm trying to say is that if you look carefully at the scatter diagram, you've really got to keep within the range of the data. Because as the age increases, how do we know that it's going to be linear? It might not be at all. And you could look at it the other way. If the age is becoming lower and lower and lower, say a 1-year-old, well, a 1-year-old might not even be running. Okay, so within the data that we've got, we can use that. That's called interpolation. And if we go outside of the data, it's called an extrapolation. Okay, so have a good look at that. Sorry it was a bit fiddly with how to explain the question, but I'm just getting used to this technology. Okay, so let's move on to the next question. Question 2. We need to expand and simplify this expression. So if we just write it out, we're going to do 5 lots of this bracket. So we've got 5p plus 15. And be very careful here. I would probably split this up and put the minus here and then look at this separately. So we've got 2 lots of 1, which is 2, and then 2 lots of negative 2p, which is minus 4p. And then look carefully, we've got 5p plus 15, and then minus 2, and then be careful, plus 4p. And if you're confused with that, just assume that there's a 1 in front of that bracket. If there's nothing written, it's always 1 times the amount. So now we can collect the terms. So we've got 5p and 4p is 9p, and then 15 take away 2, that's 13. So 9p plus 13. Question 3. There's a trapezium drawn on a centimetre grid, and we've got to draw a triangle equal in area to this trapezium. Well, let's work out the area of it first. So we can split it up into 1 shape here, 2 shapes, and then a third one. So the first one is a triangle which is 1 by 4. So you can treat this like the base, that's 4, the height as 1. So what's the area? Well, it's 4 times 1 halved. So the area of that is going to be 2 centimetre squares. This one's easy, we can just count the squares. 1, 2, 3, 4. And this one here, we've got a triangle of base 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4. So 6 fours are 24, but we need to halve it, and that will give us 12 centimetre squares. So the area of our triangle needs to be 12 and 4, which is 16, and 2, which is 18 centimetre squares. Well, if you do a base of 6, 1, 2, 3, 4, 5, 6, and a height of 6, 1, 2, 3, 4, 5, 6, well, that'll be 6 sixes are 36, but you know that you have to halve it. So half of 36 is 18. So there's a simple one that you could do. So basically, the base times the height divided by 2 has just got to be 18. So if you bring this 2 up by multiplication, it's the same as having the base times the height is 36. So don't forget, when I say height, I mean the perpendicular height, i.e. the height that goes straight up at right angles to the base. So in this case we had a height of 6 centimetres and a base of 6 centimetres, and that gave us our area of 18 centimetre squares. So there's many different ones you could do, maybe try a few of your own. Question 4. When a biased 6-sided dice is thrown once, the probability that it will land on 4 is 0.65. So that's given. So we can check here. I can already see an error here because that really should be 0.65. So one mistake is these are the wrong way round. And And then because this one is true but the wrong way round, then 0.35 is what this one should have been. So just to recap, the first mistake would be that 0.65 plus 0.25 here does not equal 1, because that's what the probability should add up to. So the probability of not 4 really should be 0.35. And the second mistake is here, which I identified reasonably quickly, only from the fact that we've got this is quite key here, is that the probabilities on the second throw are the wrong way round. Okay, so that wasn't too bad a question. Question 5. ABC is a right angled triangle, and I'm just going to put this angle in here as theta. It says work out the size of angle ABC, give your answer correct to 1 decimal place. Well, we're not given the opposite here, although we could find it by Pythagoras. And we've got the adjacent, which is 7, and we've got the hypotenuse, which is 11. So we're going to use cos theta is adjacent over hypotenuse, which is 7 over 11. So we can find the angle, because the angle will be inverse cos or arc cos of 7/11. So on my calculator, shift cosine 7/11. I'm writing down the entire part of the display, so 50.47880364, and to 1 decimal place, that's going to be 50.5 centimeters 1 dp. Now the second part says the length of side AB is reduced by 1 centimeter, but the length of the side BC is still 7, and the angle ACB is still 90. So it's saying that this angle stays the same, this length is preserved, it stays the same, but this length here goes down by 1. Now that's not a very good one there, so I'm going to try and do this properly if I can remember. So let's do it like so. Okay, so you can see there that what would have changed is that this length now would be 10, and this would be our new angle, so we'll call it theta 1. So we'd have cos of theta 1 would now be adjacent still, which is 7, over hypotenuse, which is now 10, because this is still a right angle, that's really important. And I think you can see using your calculator that 7, let's get rid of this ruler, shall we? So I think we can see that from here, 7/10 on your calculator is 0.7. What we had before was 7/11, and I'll do that on my calculator. 7 divided by 11, that's 0.63 recurring. So we can see that it has increased. So we note that cos, and I'm going to do cosine of ABC because theta 1 was not the same as theta 2, but ABC, if I just explain, A to B to C is the angle we're talking about. We can note that cos of ABC has increased. And that's all we need to do for that question. Question 6. There are some counters in a bag and the colours are given, and we're told first that there are 18 blue counters in the bag. So 0.45 must represent 18 blue counters out of the total. So that will help us find the total, won't it? Because if I rearrange this equation here, I will end up with t equals 18 divided by 0.45, which I can do on the calculator. So 18 divided by 0.45, that gives me 40 counters. So I now know that there's 18 here. Yellow, well, that's a quarter of them, so there's 10 counters that are yellow. It also says that the probability that the counter Bob takes will be red is twice the probability that the counter will be white. So in terms of numbers, we're going to have x white counters and 2x red. I've already got 18 and 10, that's 28, and that leaves 12 left for these in total. So 2x and x has to equal 12, so 3x equals 12, and that's x equals 4. So basically there are 4 counters here and 8 counters there. So it says work out the number of red counters in the bag. Well, we've done that now, so that's 8. And we've now got a situation where a marble is going to be taken at random from a box of marbles. The probability that the marble will be silver is 0.5, and it says there must be an even number of marbles in the box. Well, I would say something like because if odd, then 0.5 times odd is a decimal, and something along the lines of you can't have half a marble in the box. So, you know, if 0.5 is multiplied by an odd number, it will never be a whole number. So for half a number to be an integer, that number must be even. Okay, so you can write your own explanation there, but that's mine. Question 7. 5 minus x, all divided by 2, is equal to 2x minus 7. Well, to solve this equation, I'm going to times both sides by 2 first. That gets rid of this part. So we're going to have 5 minus x equals 4x minus 14. I'm then going to get the x's on one side, so I'm going to add x to both sides. And that's going to give me 5 equals 5x minus 14. And then I'm going to add 14 to both sides. And that gives me 19 equals 5x. And then I'm going to divide by 5 both sides. And that's going to give me the answer of 19 fifths equals x. And I'm going to write that just there. Now, obviously you might want to do that on your calculator. I wouldn't bother, to be honest, but 19 fifths is going to be 38 tenths, which is 3.8, but the fraction is absolutely fine to leave it like that. Question 8. This shape is a pentagon, and it says angle BCD, this angle here, is twice angle ABC. So if we call this x, then this one is basically twice the amount. So the next thing we have to work out is that all of those angles inside must add up to something. Well, one way of looking at this is we can split it up into as many triangles as we can. And we know that in a triangle, one triangle is 180 degrees, but we have 1, 2, 3 of them. So 3 triangles on your calculator, that will give you 540 degrees. So we can say that 115 degrees plus 125 degrees plus x degrees plus 2x degrees plus 90 degrees is 540. We don't have to write the degree sign in, so what we can do is we can have 2x plus x is 3x. 115 and 125, that's 240, and 90 is 330. And that's got to be equal to 540. So I'm going to take 330 from both sides. And that gives me 3x equals 210. And then I'm going to divide both sides by 3. And that's going to give me x equals 70. But that's 70 degrees, okay? So work out the size of angle BCD. Well, we know that this angle is 70 because we've just shown that. And we know that this one is twice the angle because it's given that in the question. So we know that, therefore, angle BCD is going to be equal to 140 degrees. Just one point to mention here. When we were at this stage, you may have noticed that everything here has a factor of 3. So you could have written from here, divide everything by 3, and that's x plus 110 equals 180, and then take 110 from both sides. You would have ended up with x is 70 degrees, exactly the same, but just a slightly different way. Question 9. We have an expression t equals the square root of w all divided by d cubed, and we're given the values of w and d, and we've just got to substitute them in and use our calculator carefully. To get the answer. Now, putting this in the calculator, I would think that it would be wise to have a bracket here as well. So I'll go through each step. I would leave the square root until the end. So I'd open up the large bracket in red first, and then open up another one to do the numerator. Type in 5.6 times 10 to the power negative 5. Close a bracket. Divide, open a bracket for the denominator now, and type in 1.4 times 10 to the power negative, let's get this right, (10 to the power negative 4). Close that bracket, do that to the power 3, and then close another bracket, which is the last right hand side of the red brackets, and I get and don't forget I've got to find the square root of that, which I'm going to do now. And that gives me 4,517.5 539,515. It wants the answer in standard form, correct to 3 significant figures. So that's going to be 4.52 times 10 to the power 3. Because if you think about it, this had 1 power of 10, 2 powers of 10, 3 powers of 10, and then you had to round it to 3 significant figures, didn't you? So 1, 2, 3. Okay, so 4.52 times 10 to the power 3 is what I got for part A. For part B, W is increased by 10%. So in the numerator, we're going to have the 5.6 times 10 to the minus 5 would be increased by 10%. So that's timesing by 1.1. And the D value, which is 1.4 times 10 to the minus 4, that's times by 1.05, which is an increase of 5%, but that's done 3 times in succession because it's cubed. So Lottie says the value of t will increase because both W and D are increased. Lottie is wrong, and explain why. Well, all we have to do is extract 1.1 divided by 1.05 cubed, and then don't forget we've got to square root that, and that will be the factor that it's either increased or decreased by. So if we do 1.1 divided by 1.05 cubed, again, lucky we've got a calculator, so 1.1 divided by 1.05 to the power 3, and then I'm going to do that to the power half, i.e. square root it. That gives me a factor multiple or multiplier of 0.9747929,823. I'll just write everything on the calculator, it's always worth doing that. And we can see that that is less than 1. If it was 1, then it wouldn't change. So for Lottie to be right, it would have to be more than 1, and that would increase the value of t overall. So that's enough explanation for part B. I think that's quite tough, that question. Question 10. You're given 3 lamps. You're told how many times they flash in a certain amount of time. So we've got A is every 20, B flashes every 45, C every 120 seconds. So I think this question is going to be looking at lowest common multiple or highest common factor. I think it's going to be lowest common multiple, but let's have a look. I'm going to split the 20 into its prime factors. So 20 is 4 times 5, and the 4 is 2 squared, so it's 2 squared times 5. 45 is 5 nines, and the 9 is made up of 3 squared. And 120 is 3 times 40, so that's the 3, the 40 is 8 fives, well that's the 5, and the 8 is 2 cubed. And the way of finding the lowest common multiple, which is really easy, is you just look down each column and you choose the highest power that you've got. So 2 cubed. In this column, 3 squared. And in the last column, 5 to the power 1. They all share that anyway. And if you think about it, why would that be the case? Well, all of them would have to have 2 cubed in them for the lowest common multiple to work. So this wouldn't have any, so it would definitely need to have 2 cubed, and this would only need to have one more factor of 2 to make it 2 cubed. So they'd all have to have 2 cubed at least. In this one, well, 3 squared is the highest, so this would need one factor of 3 to make it 3 squared. This would need 3 squared because it hasn't got any, and in this case they've all got the same. So to find the answer, all we have to do is just multiply these numbers together. So 2 cubed is 8, we do that on the calculator. So 8 times 9 times 5, and that's going to give us 360. So 360 is going to be our lowest common multiple. So what 360 tells us is that every 360 seconds they will all have flashed at the same time. Okay, that's important. So every 360 seconds they'll have flashed exactly at the same time, but you've got to find how many times they do that in the space of 1 hour. Now 1 hour is 3,600 seconds because it's 60 minutes and each minute has 60 seconds. So all I'm going to do is do 3,600 divided by 360. You can do that on the calculator, or you can just see that the answer is going to be the same as 360 divided by 36, which is 10 times. Now, I think you could get away with saying that, or 11, because the 3 lamps start flashing at the same time, so that would be 1 extra time, and then after 360 seconds they do the next one, and so on for all those 10 times. So I've looked at the mark scheme. You get marks for saying 10 or 11, okay? But 10 is probably going to be the most popular answer. Question 11. In 2003, Jerry bought a house, and why don't we call that X pounds. In 2007, Jerry sold the house to Mia. He made a profit of 20%. Well, to increase something by 20%, you want to times it by 1.2. So that's what he sold the price. That's the house price that he sold to Mia. In 2012, Mia sold the house for £162,000. She made a loss of 10%. So if you want to reduce something by 10%, you times it by 0.9. So just to recap, this was the price that we want for the house that Jerry bought. He made his 20% profit. Mia made her 10% loss. But it tells you in the question that the house was sold for 162,000. So we can put that equal to 162,000. So on the calculator, I'm just going to do 1.2 times 0.9. So that's 1.08x equals 162,000. And then I'm now going to divide both sides by 1.08, and I'll do that on the calculator. And I get £150,000 as the answer. Question 12. The graph shows the volume of liquid in a container, and we're asked to find the gradient of the graph. Well, the first thing we can do here is look at how much x changes here. So we've got 8 units across here, and then how far we go up. And that started from 4 up to 16, which was 12. And so the gradient is the change in y over the change in x. So we've got 12 over 8. And on the calculator, that will give you 1.5 or 3 over 2. It's up to you what you write. Explain what this gradient means. Well, what it represents is the change in volume with respect to time. So it's how the volume changes as the time changes. So I can write that here. So I'll say rate of change of volume with respect to time. And it now says that the graph intersects the volume axis at L equals 4 here when t is 0. That's important. Explain what this intercept represents. Well, to me, it tells you the volume or the amount of liquid in the container at the start. So it tells the volume of liquid in the container at the start. And we can write in brackets there, t equals 0. Question 13. Here are two similar solid shapes, and it says the surface area of shape A to the surface area of shape B is the ratio 3 to 4. But before I write that down, I'm just going to do a little table here, length, area and volume, and we're going to have shape A and shape B, and we're given 3 to 4 here, and that's as an area. So how do we move from an area to a length? Well, we have to square root, don't we? Because if we want to find area, we multiply lengths by lengths, okay, i.e. squaring them. So to get from an area to a length, we have to square root. So we're going to have root 3 to 2, because the square root of 3 is root 3 and the square root of 4 is 2. And then we can move to the volume from the length by cubing. So that's going to give root 3 cubed to 2 cubed. And we can simplify that a bit. That's root 3 times root 3 times root 3, which is 3 root 3. So I can make that a bit easier. So we've got 3 root 3, and here, instead of writing 2 cubed, I can just write 8. Now it says the volume of shape B is 10 centimetre cubes. Work out the volume of shape A. Well, what I'm going to do is, for shape B's volume ratio, I'm going to divide both sides by 8. So that's going to give me a unitary ratio here for B. And then I'm going to make the right hand side 10. So I'm going to times 1 by 10, which gives me just 10. And I'll have to do the same to this side. And then I'll put this in my calculator, and that will be the volume of shape A. So let's see what we get. Well, my calculator gives an answer of, let's put this down properly, I get 6.495190528. That's a bit untidy there. Neaten that up. And we want it to 3 significant figures. So this 5 here rounds to 9, and we're going to get 6.50 to 3 significant figures. But what do we have? The units are centimetre cubes. So I get 6.50. Question 14. There are 16 hockey teams in a league. Each team played 2 matches against each of the other teams, and we've got to work out the total number of matches played. I think the approach of this one should be something like a space diagram. So for example, if you have the teams down here, and obviously I'll miss out some of them, I don't have to do all of them. So this would represent Team 2 playing Team 1, and this would represent Team 1 playing Team 2. The whole space is an area of 16 by 16. So on your calculator, if you do 16 times 16, you're going to get 256. Now, we can't have Team 1 playing against Team 1, can we? Or Team 2 and so on, all the way up to Team 16 playing Team 16. You can't play yourself. That would make no sense. So we have to take those 16 diagonals off. And that would give us the answer that we require, 240. And why would it be the answer? Well, each team played 2 matches against each of the other teams. Well, Team 1 playing Team 2 and Team 2 playing Team 1, well, that's 2 matches and it's the same teams involved, Team 1 and Team 2. So that's my way of tackling this question anyway. So the answer is 240 matches played in total. Question 15. The graph shows the speed of a car in meters per second during the first 20 seconds of a journey. We've got to work out an estimate for the distance of the car travelled in the first 20 seconds, and it says use 4 strips of equal width. Well, we know speed is distance over time, so the distance travelled is speed times time, so it's basically the area underneath this curve from 0 up to 20. So I'm going to split this up into these shapes here. Of course, you'll use a ruler in the exam. And these are going to be trapezia here, and this one's going to be a triangle. So I'm going to split this up into 4 strips, and they have equal width because they're all 5 here. So for the first one, that's the area of a triangle, so that's 5 times the height here seems to be 22 halved, plus, well, the area of a trapezium is the height, which I'm going to use as 5, over 2 lots of this height here, which I've already got, which is 22, plus this new height here, which is 28. And then I'm going to add it to the next one. So that's 5 over 2 lots of 28 plus this new one, which is 32, and then plus 5 over 2 lots of 32 plus this last one is 35. Now, when you come to do A level, if you do, then there's a quicker way of doing this. I'll explain this really quickly. You can see that these are shared here. Basically, the height here is used twice. It's used by the first one and the second one. This height here is used between the second and third, and this one is shared between the third and the fourth. So you could have written here 5 over 2 and had 1 lot of the 22 plus 2 lots of the 28, because that's used twice, 2 lots of the 32 because that's used twice, and then just 1 lot of the 35 at the end. And then our triangle is separate. Although at A level you can say here that this is a trapezium of one of the heights is 0 and the other one is 22. So that would give the same answer. But we'll use a triangle here at GCSE. So we'll have 5 times 22 over 2. And now I'm just going to put that in my calculator. I'll do the first bit separately. So that's going to be 55 plus 5 over 2 lots of, well, I'll have 22 plus 2 lots of 28 plus 32, close the brackets, plus 35. That's going to give me 177 in there. Of course, if you want to do each in turn, that's fine also. And so I'm going to have to do 177 times 5 over 2. So times by 5, divide by 2. So that gives me 442.5 for this part. And then I've just got to add 55 to it. So I'm going to do that now. And I get 497.5. And we want the distance, so we're going to say meters. So 497.5 meters. The mark scheme allows you to have between 488 up to 507, depending on what kind of method you use. Some people can use rectangles and a triangle. So they might have slightly different answers. Now, the next part of the question says, well, if I can get this to work, let's have a look. Right, that has to get rid of all of this, but never mind. It says, is your answer to part A an underestimate or an overestimate of the actual distance the car travelled in the first 20 seconds? Well, if you think about it, all of our shapes were underneath the curve, weren't they? So the area we found would have been not enough, i.e. An underestimate. So as the areas of the shapes used were under the curve, we would have an underestimate. For the distance. And again, if you just zoom in here, you can see this is why it's an underestimate, because all these parts here, if I can just do that without messing up. I don't think I can move this anymore. Let's have a look if I can do it like this. So this part here, and this part here, here, and here, that would be what our method was underestimating by. Okay. Sometimes when you have a question, you have a graph that goes like this, and then when you do your trapezium like this, they are sometimes over. Yeah, it's not a very good diagram. I'll do another one here. What you actually have is something where you overestimate it because your shape is over the actual curve. Okay, so I think it's just practice with these questions really. You'll get used to them. Question 16. The nth term of a sequence is given by an squared plus bn, where a and b are integers. It says the second term of the sequence is -2, so when n is 2, we have 4a plus 2b, and that's going to be equal to -2. The fourth term of the sequence is 12, so when n equals 4, we'll have 4 squared, that's 16a, plus 4b, and that's going to be equal to 12. It says find the sixth term of the sequence. So what we can do is solve this pair of simultaneous equations. So what I'm going to do is I'm going to divide, I'm going to call this equation B, this one A. I'm going to divide B by 4, and that's going to give me 4a plus b equals 3. I'll call that equation C, and I'm just going to write a underneath. And then I'm going to multiply one of them by -1. It doesn't matter which one. I'll do this one. Call that a prime. And I'm just going to add c and a prime together, and that's going to give me minus b equals 5. So b is going to be -5. And I can substitute that into c, and that's going to give me 4a plus b, which is -5, equals 3. I'm going to just write this more clearly for you. I'm going to add 5 to both sides and divide both sides by 4. So a is 2 and b is -5. So what does that mean for our an squared plus bn term? What's that going to be? Well, it's not going to be in terms of a and b now, because we have a and b as 2 and -5, which are integers, so we need to check that. So we were given our function, say f of n, and that was an squared plus bn, but we found a and b, so we can say that's going to be 2n squared minus 5n. And the question wanted us to find the sixth term of the sequence, so yeah, we're just going to put 6 in here. So we're going to get 2 times, and be careful, it's 6 squared times by 2. And then we've got 5 times 6 here, which is going to be 72 minus 30, which is 42. So the sixth term is going to be 42. Now, what we've got to do now is find an expression in terms of n for this sequence: 0, 2, 6, 12, 20. Well, I'm going to look at the first differences. So that gives us 2, 4, 6, 8. Now the second differences, and they're all the same. So without going into loads of detail, you always halve the second difference to give how many n squares there's going to be. So there's going to be 1 lots of n squared, or just n squared. We then write down the square numbers: 1, 4, 9, 16, 25, and so on. And then we just compare. So what do we have to do to 1 to get 0? Well, we have to take away 1. What do we have to get from 4 to 2? We have to take away 2. From 9 to 6, take away 3, and so on. So can you see that we just have to write down, and I'll get a bit of space for you here. So hopefully what you can see is we take the square numbers and we just take away n each time. Because if you think about it, n would just be 1, 2, 3, 4, 5, and so on, and it's that we're taking away each time. So we're taking away 1, then 2, and then 3, and so on. So you could write n squared minus n, or you could just factorize it and say n lots of n minus 1. If you were unsure, what you could do is you could just try on one of the terms, so say the fifth term here, and you could just substitute n for 5, and that will give you 5 times 4, which is indeed 20. So that will give you a bit more confidence. Question 17. It says work out the length of AD. Give your answer to 3 significant figures. Well, is it true that using the sine rule that BD over sine 34 is equal to 12.5 divided by sine 109. Well, let's have a look in the triangle. So we've got BD, which is here. So BD over the sine of 34 will be 12.5 over the sine of 109 in triangle BCD. So we can work out BD, and that will be 12.5 sine 34, I'll do that in brackets, divided by sine 109. I'll do that on my calculator. So 12.5 sine 34, I'll press enter and then I'll divide by sine 109. If you don't want to do that, you can open a bracket, put in 12.5 sine 34, close the bracket and then press divide sine 109, and you'll get 7.392674744, but to three significant figures you'll have 7.39 centimeters to 3 SF. That's BD. So we've got this far, and we want AD. So we want this one here. I'll put a question mark by it. So if we have this one here, and we want to find this one, can you see that we've got the angle 86, we've got this length now, and we've got this one. So what we can use is the cosine rule. So I'll just create a bit of space. So the way I look at it is, I pretend that this is a right angle triangle. If it was, I would have BD squared plus 11.4 squared would be equal to AD squared. However, it's not a right angle triangle, so I would have to take away this correcting factor. So I'd have BD squared plus 11.4 squared minus 2AB times BD cos 86 equals AD squared. Now, what I have here is a situation where I've got AB already. So just to recap, this is the Pythagoras part, and this is like the correcting factor. And the correcting factor is always to do with the lengths that make the angle which isn't 90. Okay, so that's a nice way of remembering the cosine rule in this situation. So we have AB as well. So we're in a situation where BD is given, so I'm going to put that as ANS on my calculator so it's stored in there. So I'm going to have ANS squared plus 11.4 squared minus 2 times 11.4, because don't forget I have AB, times BD, which is ANS, cos 86, and that's equal to AD squared. So what I'm going to do is just put all of that in my calculator, and then at the end I won't forget, I'll try and square root it so I get the answer wrong. So I've stored that in my calculator, and I'm just going to type in this now. You may not use the ANS button, you might have another way of doing it. If not, be very careful, do not put this one in for BD, put the long one in, the unrounded one, okay? So be very careful with that. And I get AD squared is 172.8539781, and now I'm going to square root, so AD would be 13.14739434, but it wants it to three significant figures, so we'd have 13.14 1 centimeters to 3 SF. I've just seen one thing which is a bit strange. I don't know why I did this. I don't know why I gave this one actually to 3 significant figures at all, because I didn't need to. So apologies for that. Just use this one and store that as ANS. Okay, so you can scrap this. So just to recap on the question, I used the sine rule first, and then I went into the next triangle. So I had triangle 1 first. I worked out what I could in that one, and then I moved on to triangle 2 to get the length that was required. Okay, so mixture of sine rule and cosine rule there. Not easy for some people, I understand that. Question 18. Show that the equation x cubed plus x equals 7 has a solution between 1 and 2. Well, I'm going to rearrange this equation and put it equal to 0, and then I'll call that f of x. So f of x is x cubed plus x minus 7. I will put in the value of 1, so I'll do f of the value 1, which is 1 cubed plus 1 minus 7, which is 1 plus 1 minus 7, which is negative 5. I'll create a bit of space here. I'll then do 2 into the function, which is 2 cubed plus 2 minus 7, which is 8 plus 2 minus 7, which is 10 minus 7, which is 3. And I hope you're well versed in doing this. I've seen a change of sign. So there's a change of sign, i.e. it goes from a negative number to a positive number, which means it would have to cross 0 and there'd be a solution. So a change of sign implies solution between 1 and 2. There are other mathematical ways of writing that, but that's fine to write this for now. You can say, so I may as well say it, and therefore root lies on the interval 1, 2. So you can do that. Okay, right, so part B, we need to show that the equation x cubed plus x equals 7 can be written as x equals the cube root of 7 minus x. Okay, so that's what you want to show. Now, what I'm going to do first is I'm going to take x from both sides here. So that gives me x cubed equals 7 minus x. And then I'm going to cube root both sides. So x will be 7 minus x cube root, or you can just write 7 minus x to the third, which is exactly the same. Part C says starting with x0 equals 2, i.e. our first value, we're going to put into the iterative formula. And our iterative formula is like so. So to find the next one, we're using old values, and we start here. There's many ways of doing this, and I shall leave that for you to decide how you're going to do it. You can put it straight into the formula every time and keep restarting the whole formula, or you can put in the value of 2 with a starting position of ANS, and then do 7 minus ANS all cube rooted, and keep pressing the equals button, and it will automatically do it for you. But that depends on what calculator you have. So I'm just going to give you the values that I get. So I had x0 was 2, obviously, x1 came out to be 1.70997597. x2 was 1.74241880, and x3 was 1.738849,506. One thing to note is on another video of mine, I have explained this by doing a little mini video within this video of how I use the calculator to do it. So you'll just have to look through some of the past ones I've done, and you'll see me explain it in more detail. So it does ask us here to find an estimate for the solution of this equation. So I would look very carefully, and I would say either to one decimal place they're all 1.7, so you could say 1.7 to one decimal place, or you could say, and I think the mark scheme does allow this, they seem to both round to 1.74 on the second and third iteration, so you could get away with saying 1.74 to two decimal places. So on the mark scheme, I think this is the predominant answer, but it allows you full marks for this one as long as your iterations before were correct. Question 19. There are two right-angled triangles, and it says that tan E is equal to tan F. So tan E is opposite over adjacent in this triangle. So that's x over 4x minus 1. And tan F, well, that's opposite over adjacent in this triangle. And it says that tan E equals tan F. So from that we can say x over 4x minus 1 is equal to 6x plus 5 all over 12x plus 31. So what we can do now is try and solve that equation. Now that's not easy, so we'll take this reasonably slowly. Now what I would do is times both sides by the denominators. So I'm going to times both sides by 4x minus 1, 12x plus 31. That's both sides. Some of you will just know the idea of cross multiplication, but that's exactly the same thing. So for those that aren't sure of this, I'll just show this step. So if I times that side by this, then what's going to happen? This is going to cancel with this, and I'll just be left with x lots of 12x plus 31. And on the other side, I had 6x plus 5 over 12x plus 31. And I've got to times that by the same thing. And what happens there? This one cancels. Okay? And that's why when you write out what you're left with, so we have an x and we have 12x plus 31. That's equal to 6x plus 5 times 4x minus 1. Okay, so that's the idea of cross multiplication, but cross multiplication is just an idea, and mathematically you're actually doing this to both sides. So what we can do now is we can multiply out the brackets. So we've got 12x squared plus 31x, and that's equal to 24x squared minus 6x plus 20x minus 5. We can simplify on this side. So we've got negative 6x plus 20x, which is 14x, minus 5, and then we've got 24x squared there. And on this side, we've still got the same. So what I'm going to do is I'm just going to move this up a little bit to give us a bit more room. So from here, what do we do next? Well, I think I'd get the x squared terms, the x's and the numbers all on one side. And as I've got more of the x squares here, I'm going to start by taking 12x squared from both sides. So let me just write this out neatly here. So I'm going to take 12x squared from both sides. And that's going to leave me with 31x equals 12x squared plus 14x minus 5. I'm now going to take 31x from both sides. And that's going to leave me with 0 equals 12x squared. Now, 14 take away 31, that's going to be negative 17x minus 5. We can then look at the right-hand side and factorise that into two brackets. And from that, we've got 4x, 3x, and we've got here minus 20x plus 3x will give us our negative 17x that we required here. So solving each bracket equal to 0, that's going to give us x is negative a quarter, and solving this one equal to 0 is going to give us x is 5/3. Now in the original question we had x was a length in one of the triangles, so I think it was x and 4x minus 1 when the angle was e. So we're going to choose the positive value, x equals 5/3, and ignore x equals negative a quarter. Question 20. 50 people were asked if they speak French, German or Spanish, and we've got a list of details here. I've drawn a Venn diagram with French, German and Spanish shown. I think the easiest one to look at first is this one. 2 speak French, German and Spanish, so that will go where they all intersect. It says 4 speak French and Spanish but not German. So French and Spanish is going to be this overlap here. But it says 4 speak French and Spanish but not German. So they don't speak any German, so they can't be in here. So they'd have to be here, 4, where French and Spanish overlap but doesn't include German. So we can put that one in. Then 7 speak German and Spanish. Well, to speak German and Spanish, you'd have to be where German and Spanish overlap, okay? Because that would show that you speak both those languages. And it wants 7 people there. So we've already got 2. So we're going to have 5 in here. It says 8 do not speak any of the languages, so that's easy enough. We can put that in here. It says all 10 people who speak German speak at least one other language. Well, if we look carefully here, we've got 5, 7, we need 3 more, but all of those people have to speak at least another language, so we can't put the 3 in here because that would just mean German on its own, so we'd have to put the 3 here. Then go back up to the top. 31 speak French. Well, we've already got 4, 6, 9, so that would leave 22 in here. So what have we got so far? We've got 22 and 8 and then 3, 2, and 4, and 5. So if we add those up, we're going to have 10, 13, 15, 24. So that's 44. So there's 6 left. So can you work out where you think they go? Because it's very conclusive that 31 speak French. All 10 people who speak German have been accounted for. So the only room that the remaining 6 can go is in here, which I think is quite difficult. So that leads us on to work out the question now, which is 2 of the 50 people are chosen at random. Work out the probability that they both only speak Spanish. So from the diagram, only speaking Spanish, the first person, the probability would be 6 out of the 50 people. And then for the second person, well, 1 has already been chosen, so that would remain 5 Spanish people left out of a total of 49 people to choose from. So on the calculator, you've got the answer of 30 here out of, so 50 times 49 is 2,450, and your calculator should cancel that down. You can see that from here as well. So you're going to get 6 out of 490, and you can cancel that even more. I think my calculator, if I just do 30 out of 2,450, it will give me as 3 245ths. And either of these answers will be absolutely fine for full marks. Question 21. We're given ABCD is a parallelogram, and ABP and QDC are straight lines, okay? And we're also given angle ADP and angle CBQ are 90. So just to point out here, 2 important features already for this question are you're given that this line is parallel to this one, and you're given that these are right angles. That will come up later. So prove the triangle ADP is congruent to triangle CBQ. Well, what I would do is I would do 2 smaller diagrams of those triangles. Label this one A, P, D, and this next one Q, B, C. And then I'm going to try and fill in some information that I know. So I do know that this angle here is a right angle, and I know this one is a right angle. So I'm going to write that first. So angle ADP equals CBQ is 90 degrees, given. I also know that opposite sides of a parallelogram are equal. So I also know that AD equals BC because it said ABCD is a parallelogram. Okay, so if I just show you this here, so A, B, C, D would mean that AD is the same as BC because opposite sides of a parallelogram are equal. There's quite a bit of writing to do in here actually. So opposite sides of a parallelogram are equal. I'll try not to write over the marks, are equal. So there's 2 facts, and then the last one is angle PAD, so this angle here must be the same as angle QCB. So QCB. So I'm going to write that down. So PAD, and I'll give you the reason in a moment. So PAD equals QCB, and that is because opposite angles in a parallelogram are equal. So you've got opposite sides, opposite angles, angle given. So if we look at our original diagrams, then we know that AD and BC are the same. We know these angles here are the same, and we know that PAD and QCB are also the same. So what we have in each case is angle, side, angle. Okay, so that would be the reason to show the congruency between those two triangles, ADP and CBQ. So the second part of the question says, explain why AQ is parallel to PC. Now, for this question, I would refer to part A. So I would start by saying AP is equal to QC from part A, i.e. the two triangles ADP, it's a lot of writing but you've got to do it, and CBQ are congruent. So where's AP? There it is. And QC is here. Now also AP is parallel to QC. Remember at the beginning I said look out for these here, okay? That's important. So we can say that that is given. So from that we can say therefore APCQ is a parallelogram. And so finally we're now at the stage where, because APCQ, and I'll just show you here, because APCQ is a parallelogram, we can finally say that AQ is parallel to PC. So I'll just write that there. So therefore AQ is parallel to PC. I don't like these type of questions. I find them really difficult. I'm sure some of you find them almost impossible. It is a lot of practice. These questions I know are designed for the most able on the course, and I don't think a lot of people would get all of the marks on these without quite a lot of practice. So good luck with these. That's the end of this paper. Please have a look at the other papers that I've done. I've done paper 1, 2 and 3 for June 2018, the higher specification anyway at least. Okay, thanks.